Nothing beats. We are now going to look at the derivatives of the other four trigonometric functions. This is under the presumption, of course, that we have already come up with the derivatives of the sine and cosine functions. Let's get going here. All right, so like I said, we already established these two derivatives in the previous video, and that is the derivative with respect to x of sine of x is the cosine of x function, and the derivative of the cosine of x with respect to x is the negative sine function here. So we got those established. So what we're going to do is we're going to use those results to come up with the derivatives of the tangent function, the secant function, the cosecant function, and the cotangent function. How so? Well, along with those derivative results right above, we'll also use our quotient rule that we've established, since those other four trigonometric functions all involve a quotient one way or another, involving cosine, sine, or both of them. So we're going to start here with the derivative of the tangent function. So right down here, derivative of tangent of x with respect to x. And the nice thing with already establishing the derivatives of the cosine and sine functions is that we don't have to use the definition here. Rather, we can use the established quotient rule. So how so? Well, of course, if I take the derivative of the tangent function, that's the same as taking the derivative of the quotient sine of x divided by cosine of x with respect to x. So we'll go ahead and apply our quotient rule here. That's what we see right there. So we get cosine of x times the derivative of sine of x with respect to x minus sine of x times the derivative of the cosine of x function with respect to x, all divided by the cosine of x function squared. So then once I take my derivatives, derivative of the sine function with respect to x, right there, the cosine of x function times that other cosine of x right out in front. And then the derivative of the cosine of x function with respect to x is the negative sine of x function, as we see right there. And then remember this notation, when we write that little 2 above the cos, like so, that is just the same exact thing as saying cosine of x quantity squared, just as a reminder. So then now if I go ahead and multiply the numerator out, what do I get? Well, I get cosine of x squared plus sine of x squared, right? Negative, negative here. But remember that by the Pythagorean identity, cosine of x squared plus sine of x squared is equal to 1. Of course, that's an identity from trigonometry. Thus, we are left with 1 divided by cosine of x squared. And by definition of the secant function, that is the same as the secant function squared. And so what did we just show? We showed that, added to the list, the derivative of the tangent function, tangent of x here with respect to x, is the secant of x squared function. There's another result. Let's do one more here. How about if we went ahead and derived what the derivative of the secant of x function is? Right here. Well, that's the same as taking the derivative of 1 divided by cosine of x with respect to x. And so again, we have a quotient rule involved. Go ahead and apply the quotient rule. Right, in this step, we get the cosine of x times the derivative of just 1 with respect to x, that numerator, minus the numerator, 1, times the derivative of the denominator, which is the derivative of the cosine of x with respect to x, all divided by the denominator squared, cosine of x squared. And so the derivative of 1, of course, is 0. So we get cosine of x times 0 in the numerator, minus 1 times the derivative of the cosine of x function is, right down here, negative sine of x, and all of that divided by cosine of x squared. So what do we get in the numerator? We get 0 minus, or 1, times the negative sine x, so that's just a positive sine x, divided by cosine of x quantity squared. And then if we just rewrite it as a product, notice that sine of x divided by cosine of x squared is the same as 1 divided by cosine x times sine x divided by cosine x. Now 1 divided by cosine x is secant x, and sine of x divided by cosine x is tangent x. So the result is secant of x times tangent of x. And thus another result. The derivative with respect to x of the secant x function is secant x times tangent x. Added to the list. Now, of course, we could keep doing this with the other two functions. And that is, if we went ahead and applied the quotient rule to the derivative of the cotangent function and the derivative of the cosecant function, then we would come up with the corresponding results. So that might be something you want to try and verify. And if you did, what we would get is the following. And that is, the derivative of the cotangent function with respect to x is the negative cosecant squared function. And the derivative of the cosecant function with respect to x is negative cosecant x times cotangent of x. And there you go. Those are the 4 other trigonometric function derivatives. Now we got all 6, right? Including the cosine and sine derivatives. So that's the bulk of what we needed to do. Now we'll just try a couple of examples before we move on. And so let's find some derivatives using the results we just found. In this first situation, we have the derivative with respect to x of the cotan x times the cosecant of x. Now, one thing to consider is that because these other 4 trigonometric functions all have a quotient involved with sines or cosines, we could go ahead and convert everything to sines and cosines and apply our according rules. However, since we have the individual derivatives of the cotan and cosecant functions here, it might not be worthwhile to go through that whole procedure. So that's what I'm going to do, is just go with the rules we've established. Now, in this case, we have a product rule, right? Cotan of x times cosecant of x. So then what are we going to get? We're going to get the cotan of x times the derivative with respect to x of the cosecant of x plus the cosecant of x times the derivative with respect to x of cotangent of x. And so remember what these derivatives are. You can reference what we had just written above. Well, we get cotan x times the derivative of cosecant of x is, if you recall, negative cosecant of x times cotangent of x, and then plus a cosecant of x times the derivative of the cotangent function is the negative cosecant squared function here. So in the end, what do we get? We get cotan squared x times a cosecant x with a negative sign in front, and then minus cosecant cubed of x. So if we wanted, we could factor out a negative cosecant of x from both of the terms, and we'd be left with cotan squared x, and then plus a cosecant squared x. Now, keep in mind that a lot of these results we get when differentiating trigonometric functions may involve some other identities that allow us to simplify them even further. So just keep that in mind. However, in this case, there's not much else to do. So there's our derivative in part A. Let's do one more, and then that'll be it. How about if we take the derivative with respect to w now, so w is the input variable, of the product function e to the 4w times tangent of w. So again, it's a product rule. And so what do we get? We get e to the 4w times the derivative with respect to w of tangent of w, and then plus tangent of w times the derivative with respect to w of e to the 4w. And so from here, let's do our differentiation. Remember that the derivative of the tangent function was the secant squared function. We derived that earlier in the video. So for that first term, we're going to get e to the 4w times secant squared w, and then plus tangent of w, and remember that the derivative of e to the 4w would be a 4e to the 4w. And so we do have a common factor here of e to the 4w, and what do we get? E to the 4w times secant squared w plus a 4 times a tangent of w. And there you have it. So we just use the results that we came up with this video to find more derivatives. And of course, eventually we want to do a lot of things with these derivatives, look at real world situations and whatnot. And in the next video, we're going to start doing a little bit of that. We're going to start looking at some interpretations of the derivatives we've established so far in terms of rates of change. And we'll look at a really in-depth situation involving the concept of instantaneous rates of change in terms of velocity, acceleration, speed, that kind of stuff. And then we'll also look at a couple of other various examples from other fields to get a feel that, look, we're not doing all of this just to do it. We're going to do it to use it, right? And there'll be a lot more videos in terms of real world situations, more to come. So that's it for this one. Until the next one, it's Math and Beats. I'm out.